Hello, my name is Gary Grimes. I'm the Director of Sales for RF Solutions for Optical Zone Corporation. I'd like to spend a few minutes to give you a quick overview of our GPS over fiber solutions. The primary product is our GPS fiber transport, which is the only such product approved by all of the U.S. mobile wireless carriers. This signal is used as a timing reference for network sync, which could either be a direct connection to the base station radios or BBUs, or it can be a connection to a grandmaster timing server at the network hub, which then generates the PTP sync signal, which gets sent to all the base station radios over the backhaul connection. The fiber transport is a coax cable replacement between the GPS antenna and the BBUs or E-node Bs. In fact, it's generally recognized that the standard practices in the US wireless market is any connection that's over 250 feet, you pretty much have to use the fiber connection. So distance is one issue, and the other important application is for distribution. So when you have many BBUs at a CRAN hub, or a lot of base station connections at a base station hotel, that would be, say, for a neutral host DAS site, then coax becomes impractical. Running a lot of half-inch coax around the room just becomes impossible. So the fiber transport solution provides a low-profile, simple way to distribute the GPS over thin fiber cable. This is the product here. You see the fiber transmitter, which is the antenna unit, which connects to the GPS antenna. It could be one or two connections. The unit can be mounted indoors or outdoors. And then the base unit, which is the rack-mounted unit you see at the bottom, has the SMA connections on the rear panel. Actually, those ears can be mounted either way, so the chassis can be installed in a rack either way. And this is available with either 8 or 16 outputs. Here's a typical installation, just a simple point-to-point, where we have say a DAS deployment at a hotel, and there's several sectors and a number of services, and you see the active antenna, lightning arrestor, our antenna unit. We're showing remote power with minus 48 volts, so it's getting the battery backed up power from the base station. It can also be powered locally with AC power if that's not practical. And then the base unit, which then connects to the BBUs or the E-node Bs at the bottom. We're showing 8 outputs in this case, but like I said, it could be 8 or it could be 16. For a distributed GPS, the product is spec'd so that it can handle the additional loss of an optical splitter. So you could run the fiber from the antenna unit into a 1x2, a 1x4, or a 1x8 optical split to go to multiple receivers, which are then distributed at the CRAN hub. So in this particular case, we're looking at a version that's depicted with the 2 antennas connected. WDM internally puts both channels on a single fiber, and those are distributed to all those base units you see. Then the base units shown have an auto redundancy feature where internally there's an RF switch which selects one path as the primary, and if there's any alarm condition, it'll automatically flip to the backup. You see also that base unit, as indicated here, is NEBS level 3 certified, so that it is permissible to install it in central office locations. This is an example here of a CRAN hub deployment. The picture at the lower right, you can see the four of the receivers have been installed in the racks. The Ericsson BBUs have not yet been installed in this picture. They will go above and below those base units with just a thin RF jumpers going from those SMA ports to each of the BBUs. You see above that, you see the 1x8 optical split, and on the left you see the antennas on the rooftop and the antenna unit connected to it. So this has a major advantage compared to any other solution. It's very compact and lower cost than any other solution out there. As I mentioned before, it's the only one approved by all the carriers. It's very simple to deploy. There's no software needed. It actually integrates its simple alarms into the existing base station network management system, and at the same time, or into the local, like a DAS, for instance. If you have a DAS network management system like Z squared, easy integration without having to set up a separate SNMP or any other software. The next solution here was requested by the carriers to provide GPS directly to the radios at the edge of the network. So for 5G especially, the small cells need to be at the edge of the network, close to the users, to get the actual throughput that you expect. However, in doing so, the small cell radios can be very far from the hub, which means that the PTP timing signal coming over the backhaul may have to go through 10, 12 switches, routers, repeaters before it gets to the customer premises. And each time it goes through one of those hops, there are errors introduced in the sync signal. One way to correct this would be to deploy an edge grandmaster at the customer premises, but this is not always possible. So this architecture here would be an alternative. So obviously, if you have distributed small cells at a facility, many of them are going to be located far from a window or from the rooftop where the GPS signal would come in. So our distributed fiber GPS solution here takes care of that. You can see it's a very simple implementation. The one shown here would be if the small cell were like a Nokia MBO, which actually has a fiber backhaul, in which case we're taking single GPS antenna off the roof, antenna unit, we're coming down to a optical splitter, which is co-located with the router for the backhaul. And we take one of the unused fibers going to each location and we route that into our compact base unit. In this case, it's a small box that's maybe 3 by 5 inches that converts the signal back to a single GPS port that connects to the auxiliary GPS port on the small cell. And these are powered locally with just an AC adapter, since that is, in this case, that's available. So very simple deployment. The alternative to this is shown here, where you've got, say, an MBI type of small cell that has a twisted pair backhaul, in which case we're going to have the same architecture as before, but we're running a fiber alongside the Cat6, and the Cat6 actually plugs into our compact little base unit, and it provides just a pass-through on the data, but we tap off the PoE++ signal to provide power to our unit, which draws very little current, so it has no impact on the small cell itself. So once again, cost effective, you're not pulling any more cable than you normally would, and just easy to maintain. Those same components can actually just be used in a simple point-to-point connection. If you were back at the hub and you need to make the fiber connection for the GPS to the grandmaster itself, then you see that these components install very easily. The antenna unit, this particular version of it, it's got a hybrid connector with power and fiber on the same connector, so a single connection, and that runs over a hybrid cable to the base unit, and then a single power injector, which is like a PoE++ type of power, is injected at the base unit, and then there's the single connection to the grandmaster. So once again, very simple installation, very low profile. The last component I want to mention is our GPS, what we call our SkyShot GPS tester. This kit is extremely useful for commissioning and verifying that you actually have a GPS signal coming in and that you have lock, independently of the small cells or BBUs that may or may not be connected yet. So you see it's a small handheld device, battery power with an on-off switch, and it comes with an adapter that'll can plug in for charging. The first simple way to do a check is you simply connect a short jumper, which comes with in the kit from the SMA connector to any of the GPS ports that are going out of our transport and into the BBUs or small cell. If you have GPS lock, then the GPS receiver chip inside will indicate that with a blinking green LED here on the unit itself. For more detail, you can plug in your laptop to the micro USB port, and with the app that's on this thumb drive that you can just run directly from the thumb drive, you get an exact readout of all the satellites that are in the constellation that you're picking up, including you see those bars that are color-coded, the ones that are blue are the ones that are actually part of the sync, and the ones that are not being used. Plus you get a readout of the carrier to noise, so the actual signal level. And you can record this session and save it as part of your commissioning document and compare it to anything later. So for a kit that's around $1,000, you get all the information you need without the need for a $10,000 piece of hardware. So this is an extremely useful tool to have in your kit. So I'd like to thank you for your attention. There's a lot more detail available on all these products, so please contact me or contact the company. Any of these gentlemen here would be happy to help you with any questions you may have. Thank you very much.